I'll very quickly explain how to do matrix multiplication, but honestly most people don't have so much trouble with that because it's very easy to follow the instructions. I'll do that, but then I'm going to go over why matrix multiplication works the way it does, or what the idea behind it is. Because in most books, I don't see an explanation at all. In bilinear algebra, it doesn't have an explanation. And in high school, I never heard an explanation. In many college classes online I've seen, or like in the MIT Open Course, it's not explained as well. None of them are explaining what's going on there. So I'll try to do my best to explain what the idea is behind it, because I think that is really what confuses people the most. Is you learn how to multiply matrices, and yeah, you just follow the instructions. It's not hard to do, but you think to yourself, what am I supposed to do with this? I don't even know, or what am I doing even? So I'll try to explain that. But first of all, just how to do the matrix multiplication itself. The first thing, there needs to be an equal amount of entries in the row as there are in the columns. So here there are 1, 2 in a row, 1, 2 in a column, so that's fine. But if something like this were to happen where there are 1, 2, 3 in a row and only 2 in the column, then this cannot be done. But if we added a couple more here, now there are 3 in a row and 3 in a column, so the multiplication is fine. And to carry out the multiplication, it's pretty simple. We begin with the top row and multiply A times E and B times G. And if there were 3, then it would be X times E, A times G, B times W. So just like that. And this gives, if this were a matrix, see, just like A times E plus B times G, it would give the first entry there. And then we use the same row and continue on into however many columns there are. The next one would be A times F, B times A plus B times H, A times F plus B times H. That gives the second one. And we continue going until we run out of columns. And then we proceed to the next row and do the same thing. C times E plus D times G gives this one. Then C times F plus D times H. I wrote that over here. And you just keep going until you run out. And that's how the multiplication works. And that is just the mathematical way of writing it. It's just row times column. They have to have equal amount of entries. If you want a particular entry for the new matrix, this is the way it's written out. But now on to why matrix multiplication works the way it does. It's easiest to think of it as an f of g of x function. So if I have 8x, this is f, and g is 2x, then f of g of x would be like this. Okay? So I'm going to continue with this idea, and we'll start over here with just this bland system of equations. A11 times x1 plus a12 plus x2, or times x2, is equal to c1. a21 x1 plus a22 x2 is equal to c2. So my variables are x1 and x2, or you can think of them as x and y. You can write them however you want. If you're having real difficulty understanding this, then just write it out. And write it out however, with whatever variables you want. I'm just going to use it like this. So if I write this into a matrix, I have A11, A12, A21, A22, and then in a separate matrix, this is a separate matrix over here, C1 and C2. Now, here's going to be where the understanding is going to take place. Suppose I wanted to substitute for x1 something else. Say b11 y1 plus b12 y2. x2 is equal to b2 y1 plus b2 y2. So now what I'm going to do is substitute the new terms in for x1 and x2. And they're going to be y1 and y2. If I were to write this out into a matrix, it would be b11, b12, b21, b22, and then y1 and y2 are the variables. So essentially what I'm going to be doing is substituting these things in for x1 and x2. And if I go ahead and do that, I substitute this in for x1 and this for x2. Now this is what I get. I just substituted these equations where x1 and x2 were. And this is what I get. And then if I rearrange this and organize it so that the y1 and y2 are together, all I'm going to do is just multiply this out and then rearrange it into this. This is what remains. y1 times a11 b11 plus a12 b21 plus y2 a11 b12 plus a12 b22 is equal to c1, and then the same thing for c2. So if I put this into a matrix now, it comes out like this. And if I go back to my original x and y matrices, if I think of it as an x times y, then let's do the row operations. a11 times b11, a12 times b21, a11, so this times this, let me get a different color. So I'm going to do this times this, and then this times this. That's how we do the multiplication, right? And if I look over here, a11, b11, a12, b21. So just like the multiplication, right? And then if I go on to the next one, then it's going to be these two for the next entry. a11, b12, a11, b12, a12, b22, a12, b22. Just like that. And if we do it for the next one, a21, b11, a22, b21. So you can see how the matrix works out. It's just a substitution. So go back, and to understand this, just start here with a regular matrix. Just start with a 2 by 2. You don't even see this stuff. Don't even worry about this. That's separate data. So don't worry about that. Just start with either this or put whatever variables you like. And then what you're going to want to do is substitute some new set of variables in. Now if you think about it, what's basically happening here in matrix multiplication is we're taking this matrix but thinking of it in terms of these variables. It's just a substitution, that's all.